All right, let's look at an example of increasing, decreasing behavior analysis of a function. All right, so let's say you have a function given, f of x equals 2x cubed minus 3x squared minus 12x plus 5. All right, and part A says that find all critical values of f. Right? So in order to find the critical value, we have to find the derivative. So we take the derivative. So f prime of x is equal to, right? So derivative of that, 2x cubed, 3 times 2 is 6. X, then subtract 1 from the power, so it's squared. Right, derivative of negative 3x squared would be 2 times negative 3 is negative 6. Right, x to the first power. Derivative of negative 12x is negative 12. Right, derivative of 5 is a constant, so it's 0. Right, so it seems like everyone has a factor 6 in it, so I'm going to pull that out. So factor 6 out, and we get, let's see, from here you have x squared. Right, so negative 6x, so it's going to be just negative x. Right, negative 12 divided by 6 is negative 2. Right. Right, luckily we can factor this guy out, so you have 6 is already there, so we can factor it out as, so you're gonna have two quantities, right? So it's gonna be x here and x here, since we have x squared. Alright, so we have to come up with two numbers. If you multiply them together, you get negative 2. So it would be probably positive 1 and a negative 2, right? And if you add them up, we get negative 1. So it works out, right? So critical value, so derivative either equal to 0, so we're going to set that equal to 0, right? And this is a quadratic function, so it's defined everywhere, so derivative is always defined. So we're going to just set that equal to 0, and which will give you, so let's see, right, x equals, right, we can set this guy equal to 0, right? So set x plus 1 equal to 0, right? So we can get negative 1, right? And then we can set this guy equal to 0, so x equals 2, right? And these are critical values, so critical values of this function. So maybe I'll just do that. Alright, so that's part A, just finding the critical values. Alright, so let's find part B. Alright, so we want to find the intervals on which f is increasing and also intervals on which f is decreasing. So let's do that. So in order to do that, we're going to do a number line. Right, so we're going to do a number line here. Alright, then we're going to put tick marks for critical values. Say here you have negative 1 and negative 2. Right, then we're going to think about the value or sign of f prime. So f prime. Right, we know that when x is negative 1, so it's 0 right here, right? And I'm going to put a divider there, so 0 here. And add 2, right? Derivative is also equal to 0 because that's how we got 2. So here's 0, right? Then we need to determine the sign of f prime in between. So on this interval here, this interval here, and this interval there, right? There's an easy way to determine the sign. All you really have to do is pick any sample point belongs to this interval, so any number less than 1. So I'll try negative 2, right? Think of, try negative 2. So f prime of negative 2, right? So all we really need to do is determine the sine. So okay, so plug in this guy into here, right? So that's that, right? If you plug in, so we only worry about sine, right? So when you plug in, right, -2, right, -2 plus 1 is a negative quantity there, right? And 6 is already positive, so we don't really have to worry about that guy. Right, you have -2 minus 2 is still negative, right? So when you have positive times negative, it's going to be positive. So I indicate that. So this is going to be positive. That means that for the entire interval, f prime is actually positive, right? So indicate that by putting a plus sign. All right, so erase this. Right, about between -1 and 2, I like 0, so I'll try 0. So f prime of 0, right? So if you plug in 0, 0 plus 1 is positive, right? Positive quantity here, right? 0 minus 2 is negative, right? When you multiply positive times negative, the result is going to be negative. Right, that means that for the entire interval from -1 to 2, f prime is negative, right? And for the last one, anything bigger than 2, so I'll try 3. So f prime of 3, right? So let's try that. So when you have plug in 3 for x, right? So 3 plus 1 is positive, right? 3 minus 2 is also positive, so everyone's positive, so the product is going to be positive, right? So we have that. All right, so we know that when you have a positive derivative on this interval, original function f, so original function f is going to be, right, increasing here, right? And between -1 and 2, since the first derivative is negative, so we have a decreasing here, right? And 2 and the positive infinity, since derivative is positive, so this is increasing, right? So therefore, we know that f is, right, increasing on, right, so on this interval, so negative infinity to -1, so it's a negative infinity to -1, and I'm going to use a notation called union to just combine intervals, and also 2 and the positive infinity, so from 2 to positive infinity, right? Then f is decreasing on, right, interval between -1 and 2, so it's a -1 and 2, right? So those are the interval on which function is increasing and the function is decreasing, right? That's you find the that's how you find the intervals of increasing and the decreasing. All right, that's it. I hope that this was clear.